Hello, everybody. So this is problem 4 from homework 3-1 on free fall. So homework 3-1, problem number 4. And this involves two people jumping off of a bridge. And so I'm going to actually draw two bridges right here. So here's a bridge platform right there, and I'm going to draw it over here as well. A little bit thicker, but fix that. Like that, okay? And the water is down below at some distance. So that is down here. And the idea is that the first person, I'll make that person blue. All right, and actually, no, I'll make the second person blue. And the first person jumps off. Now, they're both at rest initially, but the first person jumps off and falls down a distance of 2 meters, or a displacement of 2 meters. Actually, the displacement is negative 2 meters, right? So that delta y equals negative 2 meters from here to here for that person. All right? And then when that person reaches this point right here, the other person jumps down after them, so that when this first person has hit the water, they're down here at the water, we want to know how far down the second person has actually fallen. Okay, it's a terrible stick figure. Okay, actually, we want to know how far apart they are, but if we know how far down he's fallen, we can figure that out. Because the first thing we're going to do is actually not a part of either of those. The first part is finding out how high the bridge is. So displacement for the bridge equals what? Well, we don't know how high the bridge is, but we do know that it's a 1.6 second fall. So that the time to drop from rest down to the water is going to be 1.6 seconds. Okay, so to find the displacement of the bridge, delta y bridge, the time equals 1.6 seconds. The acceleration equals negative 9.81. And what else do we know? Oh, the initial velocity is going to be 0 meters per second because they're dropping from rest. Okay, so that's what we want to find right here. How high is the bridge? Well, our displacement is going to be initial velocity times time plus 1/2 acceleration times time squared. We have that equation, and that pertains to all the things that we're talking about. And one thing we can do is we can cross out that right there, because that becomes 0. Oops, I'll get better. 0 equals 0 because the initial velocity is 0. Okay, so we can kind of assume that right from the start. So now we just have our displacement being 1/2 AT squared. All right, so this is the displacement for the whole bridge, dropping down from rest, dropping down from the whole height of the bridge down to the water. All right, so 1/2 AT squared, so that's going to be, get my calculator right here. Well, 1/2, so it's going to be 0.5. 0.5, looks like a 6, doesn't it? 0.5 times negative 9.81 times 1.6 squared. That's going to be our displacement. 0.5 times negative 9.81 times 1.6 squared. I get 12.6 meters. Or actually negative 12.6 meters because they're being displaced downwards, right? So that is the height of the bridge. I'm going to write that right there, okay? I'm going to dotted line box that. It's not the final answer, but it's going to be important to finding the final answer. Okay? Now next, we want to find out how long does it take, how much time does it take for the first person to fall down 2 meters? Because if we know how long that takes, then that means the rest of the 1.6 seconds, remember it takes 1.6 seconds to drop all the way down. The rest of the 1.6 seconds is going to be the same amount of time it takes for this person to fall down right here. Okay? So, let's find out what that T1 is right there. Well, that time we want to solve for. We know that the initial velocity is going to be 0 meters per second. Acceleration is going to be negative 9.81 meters per second squared. And the displacement, delta y, we are told right here is going to be negative 2 meters. Negative 2 meters, okay? Well, we can solve for our time. We can use the exact same equation that we did before. All right, so displacement equals initial velocity times time plus 1/2 acceleration times time squared. Initial velocity times time, that goes away, right, because initial velocity is 0. So that means we have our displacement is 1/2 at squared. So if we solve for t, that means the 2 in the denominator here is going to be multiplied up next to the delta y. The acceleration is going to be divided down, so it's going to be underneath the delta y. And then we're going to square root the whole thing because the t is squared right there. So t is going to look like this. T is going to be 2 delta y over a. Just like that. All right, so let's solve for our t. We'll call that t1 actually because that's the time of the first person dropping the first distance. Okay? Square root of 2 times, what's the displacement? Negative 2 meters. And you might think that's bad news because you can't have a negative in a square root. But remember, the denominator is a negative 2 because acceleration is negative 9.81. All right, so 2 times negative 2 divided by negative 9.81. Okay, we'll take the square root of that. And that gives us time 1 equals 0.63 seconds. All right. All right, so that's your time to drop down that first 2 meters right there. Then we can dotted line box this because this is important. Again, it's not a final answer, but it's getting us to our final answer. So how does that help us? Well, remember we said that the time that the person takes dropping from here down is going to be the same time it takes for the blue person to drop from the bridge down some distance as well. So we can say the red person's time 2 is going to be equal to the first person's time 1. It doesn't look like the time, but it is. Okay, I didn't draw it very much to scale right there. So, if it takes the first person, or if it takes any person, 1.6 seconds to drop from here down, and they've already dropped down 0.63 seconds, then how much is the rest of this fall? How much is time 2 down here? Well, that's going to be 1.6 minus the first time. That's 1.6 minus 0.63 seconds, which is what we just found out. So the time for the first person to drop the rest of the way down is going to be 0.97 seconds. Okay? So this person is falling the rest of the way down while this person is falling down here as well. They've got different speeds, all right, and so they've got different displacements, so those are different, but what is the same about them is the time. All right, the same amount of time is spent falling the rest of the way down as it is for the blue person falling the first part of the way down. So what we can say is this. The time for the first person to fall is 0.97 seconds. So let's find out where they wind up after after 0.97 seconds, and we'll be able to figure out how far apart they are. Well, what's the initial velocity of that person? That's going to be 0. What's the acceleration? It's going to be negative 9.81 meters per second squared, and we want to solve for the displacement of that person. All right, so I'm going to do it down below right here. Delta y equals initial velocity times time plus 1/2 at squared. That should be looking like a familiar equation to you. I'm going to cross that out, make that 0. So our displacement is 0.5 times at squared. 0.5 times acceleration, negative 9.81, times how long has the blue person been falling? 0.97 seconds. Oh, squared, right? I'm going to square that. All right, let's find out how far down that first person has fallen. So delta y, the blue person has fallen, is going to be 0.5 times negative 9.81 times 0.97 squared. That's negative 4.61 meters. So they've fallen down 4.61 meters. The question is, how far apart are they when the first person hits the ground? Or well, not the ground, the water. Hopefully not the ground. All right. Well, this person has fallen down 4.61 meters. What's the whole height of the bridge? Hey, we found that out before us, 12.6 meters, right? So if this person has fallen down 4.6 and the whole height of the bridge is 12.6, what's the separation right here? We can say the separation between 1 and person 2, I should make them red and blue actually, is going to be the difference between 4.6 and 12.6. 1/2, that's going to be 8 meters. That's going to be the separation between them. All right, we did a bunch of extra little calculations here because it's kind of a complicated question, but that's how we solve for it right there. So get your total distance, get the time spent falling this distance right here, and the rest of that's going to be the time spent for the both people to fall. That'll tell you how far down the blue person falls, and that'll tell you how far separated they are from the red person. All right, hopefully that helps. Let me know if you have any questions. I'll see you in the next class.